Find the domain of f of x equals 3 over x plus 1. Now in this case, because we have a variable in the denominator, we have to use the rule that the denominator cannot equal 0. And then we replace the word denominator with the actual denominator, which in this case is x plus 1. So we have x plus 1 does not equal 0. And then to get x alone, we subtract 1 from both sides. This gives us x is not equal to negative 1. If we're asked to write this in set builder notation, that'll be the set of numbers x such that x does not equal negative 1. But if we need interval notation, then the easiest way to do that, if you don't know what it's going to be, is to draw a quick sketch of the graph. So we know that negative 1 is an important number, so we want to include that. And we know that x cannot be negative 1, so that means that we've got an open circle at negative 1, but we're going to shade both sides because it can be larger than negative 1, and it can be smaller than negative 1. Just can't be equal to negative 1. So because we have this hole in the graph, that splits it up into two intervals, and we need to write both of these intervals in interval notation. The one on the left goes from negative infinity on the left all the way up to negative 1 on the right-hand side. And we've always got to use parentheses when we're dealing with infinity. And we're also going to use a parenthesis with negative 1 because that's not part of the interval. It's not part of the solution set. So we use a parenthesis there to exclude it. Then the other interval starts at negative 1 on the left and goes all the way to infinity on the right. Again, we're going to have parentheses here. And because we've got multiple intervals, we're going to use the union symbol in the middle to say that we're including both of these in our domain. And once we've got that, this is our domain in interval notation.